you can start your program.
Let's start with our today's session. A very happy morning to one and all present here. Knowledge has a beginning but no end. With this quote, in this pleasant morning, to refresh and create an impact onto the minds, Department of Electronics and Communication Engineering, Savita Engineering College, brings to you a webinar as a part of the SECEC Alumni Series Impressions on Solar Energy MPPT implementation by Mr. Varun Kumar Udayakumaran, MS in Electrical Engineering, University of Alabama. Savita Engineering College, established in the year 2001, an autonomous institution which follows the Finland-based education model, and we march towards less is more concept. Our college makes the students job ready by providing Industry 4.0 ready curriculum which imparts the 21st century skills. Project-based learning integrated with subjects improves the student's skill set and makes our learners to be the best, which is the motto of our college. The Department of EC was established in the year 2001. Our vision is to develop the department into a state-of-art with Center of Excellence in Electronics and Communication Engineering education on par with global standards. The Department of EC has well-experienced faculty of proven ability and diverse specialization. The faculty actively involves themselves in research in the fields of robotics, VLSI, MEMS, image processing, and embedded systems. I would now like to introduce the speaker of our day. Mr. Varun Kumar Udayakumaran, a Savita Engineering College graduate, earned his bachelor's in Electronics and Communication Engineering in the year 2018. He is currently pursuing his master's degree in Electrical Engineering at the University of Alabama. His area of interest is in the realm of power electronics and embedded system design. He has worked as a teaching assistant for the Department of EC at the University of Alabama. He has indulged in numerous projects as a part of thesis research and coursework. He has an inclination towards teaching. We are very happy to have you with us today, Mr. Varun Kumar. You may please take over the session now.
Thank you for the amazing introduction. I'm happy to be part of this webinar series. Good morning to all. Just want to check if everyone can hear me and see the presentation.
Yeah, it's fine.
Okay. So hope all is well with everyone with the current situation. And so today we are going to talk about the solar energy and the basics of maximum power point tracking implementation, which is the abbreviation for MPPT. Before that, I would like to take a moment to thank Savita Engineering College for providing me this opportunity, and also take a moment to thank my advisors and mentor, as a special mention to Padma Priya ma'am and Elizabeth ma'am and also Chitra ma'am for hosting me for this wonderful session. I hope you guys have a wonderful time and learn a lot from this. I would like to have an interactive session. So before that, let me give a brief overview of how we are going to proceed in this session. I'll give a roadmap right now so that you can be ready with your notes or whatever. So first, I'm going to start off with some introduction about the energy demands throughout the world, like the global requirement for energy. And then further, we will be discussing about what are the uses of understanding the global requirement and how can we understand and change towards the green energy side, and some disadvantages and advantages of different energy sources. Further, we will move on to just a brain teaser so that it's like a good warm up for you guys in this morning session. And then before we go on to the complex concepts into the implementation of the maximum power point tracking. So basically, in this session, and further after the brain teaser, it's going to be a problem for you guys to solve, and then I have the solution so that you can check if you can get the same answer for that. And further, we will have some interactive question answer session for everyone at the end of the presentation. So whatever question you have in the between, please note it down so that you can ask it at the end, and I would like to answer each and every question as much as possible. After the brain teaser, we will be talking about power converters and why it is being used in solar energy system, and then we will be talking about the control system involving how the implementation happens. So how to control the power converter to get the maximum efficiency of a solar panel. Further, we will talk about the MPPT algorithm itself. I'm taking a few algorithms so that to understand just a brief introduction of how we can implement different algorithms and make it work for the solar energy to get the maximum efficiency. So you might be wondering or having a lot of questions already. So let's begin with the session and move further. So the maximum solar power point tracking is basically an extraction of power from the solar panel. So how does that happen and where do we begin? Let's talk about a brief introduction on the global demand statistics throughout the world. In 2015, we have a projection of how much global power is being consumed as a form of different energy sources like petroleum and other liquids, natural gas, coal, renewable energy, nuclear energy. And throughout the years, we have seen recent advancements in renewable resources. And still, it is not as much given importance to just like the non-renewable resources. We will get into that later because there are some reasons for that. As you can see, these statistics are mentioned over here, like the global demand. The global demand over here states that from the year 2017 and then 2040 to show the trend in how the demand is increasing due to the various advancements in different sectors and different industries taking over to control their industrial management and services. So before we move on to the next slide, I would like to mention about these graphs. What are the uses of this graph, and why do we study this, and who is responsible for making this? Who's responsible for making this data available? We have certain institutions throughout the world who track the usage of data, the overall production, and the overall consumption by the human race. In this session, so we will be talking about just a brief overview of those instructions given by the institution to actually take the data and use it for future benefits, so that we can understand why the trend is in this fashion, so that we can work onto certain areas and fix the energy demands. It can help identify various issues like the emission of greenhouse gases and other pollution throughout the environment. How can we reduce the pollution? How can we make the environment more green? And how can we use more green energy? That is why we study the global demands and see how much of the energy is being consumed throughout. Here we have some terminologies which you need to understand. So there's actually a term called the total primary energy supply, which doesn't it is actually the total energy being produced in this whole world. It includes the oil, gas. It includes the electrical energy being generated. It includes all the different sources, except for the energy that is being stored. So the stored energy, what are the example of stored energy? For example, batteries. All the energy which is being stored in batteries are considered as stored energy. There are like trillions of batteries used everywhere, like devices, all mobile phones, laptops, and every other electronic devices have batteries and they have energy in them. So where does the energy come from? It's coming from the production which is being done in the power plants, in different kinds of energy sources, and then it is being stored in them before they are used in any kind of equipment. And then of course there are different types of losses when you are actually trying to store energy, we are going to face some losses. When you're going to transfer energy, we are going to face losses due to the release of heat. That is how we have loss in a system. And then we convert the total primary energy supply, as that is the TPES, is being converted to the TFC, that is the total final consumption, which does not include the oil and some basic power requirements. So why is that? Because we don't the oil and gas is not actually used for not just for the electricity purpose, but also for transportation, like for rocket fuel, for aeroplanes, and for normal road transportation. So the total final consumption is something apart from the overall production. So we have three divisions: the overall production, that is a complete, that is a total energy supply, and then it is then converted to total primary energy supply, which has some say the which doesn't consider the storage units, and then there are some losses, and then we exclude the oil and gas, which is used for the transportation part, and then we have the total final consumption. In the year 2013, 157.5 petawatt hours was used or was produced and consumed. And you cannot imagine how big that number is, because it is 10 to the power 15 watt hour being used throughout the world in the year of 2013, according to statistics. So who makes these statistics? The European Environment Agency, the International Energy Agency, and then the EIA, which is another agency which deals with the energy system and the data analysis, which is responsible for this graph, where they talk about the different uses, and then where we talk about the solution for world problems related to energy system and energy consumption, basically. Then so then we are going to talk about something very basic. We are going to talk about something very basic, like what is a watt? How do you measure it? It might be really simple, but when you understand when you try to actually understand the exact concept of what is it, it'll be much more interesting and much more intuitive to move further. So a current of 1 ampere pushed by voltage of 1 volt is actually 1 watt. So the watt is a unit of power, and it is the product of volt and the amps. Then which comes to the next question: what is 1 volt? 1 volt is defined as the energy consumption of 1 joule per electric charge of 1 coulomb, being 1 coulomb of charge. So 1 volt is just 1 joule over one, or how much energy is being 1 joule of energy, how much coulombs of electric charge is required to produce 1 joule of energy. And then we have the other question: what is 1 ampere? 1 ampere is defined as the current that flows with electric charge of 1 coulomb per second. And so if you combine all this together, we have an explanation for what is a watt, which is basically we can have different types of representation. The work required to move an electric charge of 1 coulomb through an electric potential difference of 1 volt. This relationship is used to define the volt, and see how the different types of explanation or different types of representation for the different terminologies, because we see it in a different fashion. We see it as different parameters. Based on different parameters, we assign different definitions and different relationship with different parameters with themselves too. So the work required to produce 1 watt of power for 1 second, or 1 watt second, is the relationship used to define the power. It is a little bit confusing, but if you actually understand the concept of what is exactly a watt, which should be useful for us to understand how the power is being transferred, and how the energy is being used, and what exactly is power and energy. That'll be the next question which we'll be talking about. What is power and energy? Are they the same? Let's see some few examples. If I just use this statement, will this be right? I went on a diet and lost 15 horsepower. What is 15 horsepower? Like, how can you convert that energy into a weight loss system like the human body? it doesn't match. It doesn't go into the understanding of how the system works here. I filled up my car's gas tank. It took 20 volts. No, the gas tank is actually measured in liters. So we don't use 20 volts. Maybe it could be a form of energy. So here we understand that the energy cannot be created nor destroyed, which is a standard. It is how it is. Like the energy can not be created, but it can be transferred from one form to the another. So basically, what exactly is energy is the capacity to do work. So anything which is capable of doing a certain task has energy. Then how is power different from energy? Power is the energy per unit time. So here we include the time factor in it. Suppose you are trying to walk a certain distance and you have the energy to walk for that distance. For, let's say we are trying to walk 10 kilometers and we have a certain amount of energy to do that task. And what is the meaning of power in that? How will you define power? If you want to walk 10 kilometers in, let's say, 1 hour, so that means you're defining a certain time. So you need to walk faster or you need to jog to go and reach at that certain time. So you need to have, so that means, so the energy you use in a certain time, so you're burning more calories. So that is the energy being used to make you do the thing faster. And there's another intuitive example I think I can give you, which could give you a certain better perspective of what I'm trying to explain. Let's say a diesel truck has to travel a certain distance. Again, we are talking about distance. And then the truck has an engine which which gives you have the details of an engine that is in horsepowers. Um, and then we have another small engine, let's say a motorbike, and then the truck engine, and then the truck is pulling a huge load and it's traveling a long distance. Can the same load be pulled by an engine by a motorbike? Yes, it can be possible, but the time will be very slow because the power, that is the horsepower of the engine, will be low, and therefore you cannot expect the bike to pull the whole load and reach within a certain amount of time. Just like how we talked about the walk for the 10 kilometer. And if you have the capacity to do work, doesn't mean that you can finish the work in a certain amount of time. If you're able to finish the amount of work in a certain amount of time, that is what is power. So here is a final term, a final conclusion of what we come to it. They're not the same. Energy is the total amount of work done, and power is how fast you can do it. In other words, power is the energy per unit time. Power is watts, and energy is watt hours. So I want you to make sure you understand this. Power is watts, but energy is watt hour. Even though we mentioned time being included in power, energy is watt hour. You will see that later when I give you the brain teaser and make you understand what's going on. So here is just a basic system of understanding how the energy is measured throughout the world. Um, right now, we just saw different graphs explaining the trend of energy being produced in different sectors. So here we have the different units and their conversion factors, like the BTU, which is the British thermal unit, which measures is equal to the 1055 joules, and then you have, which is equal to just one matchstick. You can see that over here, a representation of how one energy can be linked to certain factors for our understanding. What is 1 joule, which is another interesting factor where you can have how many BTUs. It is a baseball 2 feet above ground. So if you take a ball and you actually place it 2 feet above the ground, it has 1 joule of energy, and then it is going to fall down because it has that energy. That is the potential energy. Yeah, those are just basic concepts, but you can see the different factors over here for conversion, and different countries have different measurements. And then we can try to link our understanding with the different sources of energy. For example, oil and gas is measured in 1 mto, which is another different type of unit. And then, so this is just a brief of how you convert the energy into different parameters. Next year, I'm going to talk about just an example of an electrical grid. Uh, you might have different questions, how the energy is being produced and how does it come to our house. How do we meet the requirement? How do we set up new places? Like for example, a new industry opens, and how does the power requirement how is the power requirement met for that? Where is the energy being produced, and how is the whole system connected together? So this is just an example setup, or and just like an idea of how it's not the exact thing, but it's just a scaled down version, which means that this is maybe for a small area. You can consider this for like a small town of how the system is connected. As you can see, this is called the electrical grid distribution, where you have the coal plant, the nuclear plant, the hydroelectric energy, and the different energies which produce the power. You can see the units over here, the MW, which is meaning that megawatt. So the coal plant is producing 600 megawatt, and then you have different energy sources being produced, and then how is it being converted to different voltage requirements? As you can see, you're transmitting to through high voltage lines, and then you don't use the same high voltage line inside your house because that is not required for the electrical appliance. So we have different converters. We have transformers to actually step down the voltage and provide it for the safe use of the daily appliances in our household. And all the energy is not just circulating around the grid, it is being stored in certain places, and then it is a lot of generators being used, and many other equipments are all combined together. It is really difficult to imagine how complex the whole system is. And it's just a small this is just a small sector of what you can imagine of a big system like the whole world. um, so that's just to give you an idea of how it looks and how the energy is being transmitted. Then here is the brain teaser for you guys. So I'll just read the statement problem, and then I'll wait for you for a couple of minutes so that you can solve it, and then I'll talk about the solution. So here the statement is, consider two factories working in an area with one power plant. Given this following requirement for factories, assume no power loss while transmission from power plant to factories, provided that the factories and power plant are 24/7 365 operational. If one unit of electricity cost 1 rupee, then what is the annual cost estimated for the power supply demand of the two factories? Here's a hint for you: 1 unit is equal to 1 kilowatt hour. So this is an energy, oh my bad, this is an energy audit question. And here's a table for you which gives you the ratings of the different machines in both the factories. And I want you to calculate the amount required, that is the annual cost to maintain both the factories. I'll wait for you guys for 2-3 minutes. It's really a simple problem, and then let's see if you can get it right before we go on to complex explanations and complex concepts coming along.
If any participant is willing to answer, you can raise your hand or you can send the answer in the chat box.
Okay, we have more complex concepts to deal with. So let's keep moving forward. It's a simple problem. We can just discuss the solution. So first, how do we solve it? So basically we calculate the power. So the power is voltage into current. So we have given you the voltage and current ratings. So the basic formula for calculating power is V times I. Um, I think that everyone should be knowing that. So the machine A is 10 megawatt and the industry level cooler is 5 megawatt. The computer, the total number is 50, so each is 100 watt. So that is another 5 megawatt for all the computers. And then the food processing machine, that is a 2 megawatt usage. And then the baking machine, that's another 8 megawatt. So in total, we are going to calculate how many hours it's being used. So it's being used 24/7, 365 days. So 24 hours a day into 365 days. So that gives you the total units, total energy. This is what I meant by watt hour. So megawatt hour. This is talking about energy. Before that, this is power. So the machine A produces 10 megawatt per and then 10 megawatt hour is considered as energy, but the amount of power being generated, that is 10 megawatt. So that is in powers. So you can see how they both are very similar but not the same. They're just when time is brought into the picture, they have a different meaning to it. So the total units, total megawatt hour is 262,800 megawatt hour, and then 1 megawatt hour is equal to 1,000 units. Based on the hint that I gave you, that is 1 unit is equal to 1 kilowatt hour, and the cost for maintaining that will be 26.28 crores. Yeah, it's just a simple question. Just wanted to give you a brain teaser before we head on to the next concepts. So let's go to the next topic. Coming back to the different sources again, since we talked about the different analysis of the graph and identify a solution to world problems, we have to see which sector do we have the usage. Here is a policy statement and also a graph to explain how the development is expected in certain areas. Right now, coal is the maximum utilized energy resource. And other resources are, as you can see in the pie chart, we have a natural gas, oil, and then nuclear, hydro, solar panel, and the wind and other renewables. So why is that the green energy is very less, even though we know that it's very safe, it's like it has less pollution? Why don't we tend towards the green side of things? Why don't we try to do more of hydro, more of wind, more solar panel? What is the problem? So let's talk about the pros and cons of renewable energy. So here we have depicting certain factors when you talk about renewable sources. Yes, there are a lot of pros, but we do have some cons which doesn't let us to move further in certain areas. Like in solar panels, we have green energy, that is, it doesn't produce as much as carbon emission into the environment. Then we have the energy produced is very clean and silent. It doesn't make any noise. There's no noise pollution. And then it is approved by government and other sectors. So we have funding option to work on this sector. And then the electricity generation is direct. It doesn't have to do any complex mechanism. But it has some drawbacks which result in like damage since they're very fragile. And then we have efficiency issues when we try to convert the power. We do get power, but it's not as efficient as the non-renewable resources like the coal, which produces a huge amount of heat units and then which can be easily converted to electricity to meet the global demands. So and then there are some issues with solar energy. For example, during nighttime we cannot get the energy from the solar panels because there is no sunlight, and then we don't have and there are certain days where it's very cloudy and then it can lead to efficiency issues, and there are some additional converters required to convert the power and produce it efficiently. So this is going to cost more, and then if you consider just for one setup it may be cheap, but for if you try to scale up in a bigger sector it's going to cost more. So, and here is just a parallel comparison with the wind energy, just to talk about how the other renewable resources also having some issues. Like here we have the wind is not always present; it's intermittent. and then just like but there is some noise pollution because of the turbines being rotated, and then there is some environmental impact which can cause damage to birds and other issues like the device is like taking a huge lot of space, and you have to cut down certain trees to actually keep them in the certain place, and that's one of the issues. Other than that, the operation cost seems to be low, but there is a huge maintenance cost. It's not mentioned over here, but if there is some certain damage to any part, then you have to spend a whole lot of amount of time, energy to fix it. There you go, guys. This is just the basic reason why we are not tending towards more of renewable sources, even though we are trying to do it. So we have to face these cons and overcome these issues and deal with them. So basically in this session we are going to talk about how the solar energy can be implemented in a large sector. So for that we need an efficient conversion, we need an efficient constant power supply. And how are we going to do that? So let's move on to talk about how we will do that. Basically here we have the solar cell. Let's now we are into this. Yeah, if you have any questions still now, note it down. Just a reminder for you guys, and then you can ask it to me later. Until now, all the slides till now. If you have any question, we can you can ask at the end. So we are here. We are talking about solar. We had a good introduction about how the energy demands are met, and then now we have come to the main picture of this topic. So solar cell, how does it work? The conversion of light energy directly into electricity by the photovoltaic effect, and that is done by generating either electron hole pairs or excitons, and the separation of charge carriers of opposite types, which is like which is like producing a voltage difference between the cell. So it is basic electronic component, it's basic electronic circuit where you have the p-type semiconductor and the n-type semiconductor, which is being used to form a photodiode, which actually works under the influence of the sunlight. So what exactly happens, and then how are we using it? The sunlight is actually falling on the solar panel, and then the energy is being supplied and then controlled and used to charge batteries, and then we have converters to convert it to AC requirement, because the charge being the current being produced is a DC source, and then that is not used in our home appliances. We need an AC power supply. So we are converting it using an inverter. So the transfer of power from DC to AC is an inverter. Still, we don't know how exactly this works. We just know some terminology. So let's see a picture to describe how the exact working is. So the photons are falling on the n-type semiconductor, which is then combined with which is already combined with the p-type semiconductor, which is the solar cell, which is a single solar cell. So the photons, that is the coming from the sun, that's the sunlight. Do you think, I have a question, does the photon have any charge in it? Is the photon a charged particle or it doesn't have any charge? Let's see if you are able to answer it. I'll give you 10 seconds if you can think about something. 10 to 15 seconds before I want to grab a pen. Okay, so the photons, I don't know if you guessed it, but the photons doesn't have any charge. They're not charged material. So the particle actually, what it does is the n-type semiconductor contains more of the electrons. The dominant quantity is electrons, and then the holes is considered as the place where there's no electrons. That is, the missing of electrons is called holes, and we consider that as a positive charge, and that is more dominant in the p-type semiconductor. You can look into it of how they make p-type and n-type semiconductors. It's just a Wikipedia search. You can learn about it, how they form the solar cell, and how they form the diode, the photodiode. So the p-type semiconductors has holes, and then when the photon knocks when the photons come and the particle hit the holes, it hits the electrons, it knocks them out of their place, it makes them free, and it's free to move. Before they were just bounded inside, because it is being held between a potential difference. So there is a potential difference between the two types here. That is, this is the negative side and this is the positive side. So we have a potential difference. So what is the meaning of potential difference? That is, we have a voltage. So just like how we can consider this like uh, a system where we have a tank. This is just an analogy of how you can understand. We have water over here, and then this is considered as high potential, and this is low potential. So water will travel from higher potential. Consider there is water in this, so the water will travel from higher potential to lower potential. So same way, the electrons will travel from a higher potential to the lower potential, and then we have the metal interconnects, which are used to actually which is used to transfer the energy to the load. Here we have the load. We can use a bulb over here, so that's considered the load, and then the electrons flow, and then the current is being produced. So is it so simple as just connecting the load to the solar panel? If so, then everyone can just connect it and then make it work. What is the issue? Since the photons are not always present, the bulb is going to be flickering. It is going to flicker most of the time. It's not going to be constant. So we would be needing a regulator. In the second picture over here, where you have the cross section of the solar panel, which is another view of it, you can see how there is a regulator to have a constant DC power output. So basically, if you don't want the light to flicker or damage because of suddenly if the current peaks and then it increase, if the photons are very intense and if it peaks, and it could damage the device. So we need a regulator to regulate it at a particular value so that it is which is constant. It is a constant DC source, just like a battery. How if you have a battery, it produces the same voltage. For example, a AA battery can be 1.5 volts, and it always produces 1.5 volt. And when it stops producing that, that means the charge is being depleted. So the battery needs to be charged or it needs to be replaced. So the same case over here. So we want to have a regulator to regulate it and make it act like a battery. But regulator alone will not solve the issue for getting efficiency. Just because we have a regulator doesn't mean we can control the maximum power extraction. We do extract power, but how efficient is it? We don't extract the maximum power from it. So how do we know what is the maximum power? Before that, we need to talk about what are power converters. So here is a basic introduction. This is a more difficult concept for high school students, but this will be a good introduction for you to understand what we are talking about. This is the basics of power electronics. Here we have a power converter, which is called as we have different types of power converter. We have a DC to DC power converter, we have a DC to AC power converter, we have an AC to DC, and then we have AC to AC. So this is called a buck or a boost converter. You can call this a buck or a boost. And then this is an inverter where we have DC to AC, and then AC to DC. This happens every time in your household. It's called the rectifier, where you have AC power supply. For example, your mobile phone charger, your battery is charged with DC power supply. So we have a rectifier in the charger to convert the AC to a DC supply. And then we have the AC to AC, that is to convert one frequency to another frequency. As you know, AC power supply has a frequency, and then if you want to change from one frequency, for example, if you want 50 hertz of AC signal and convert it into 100 hertz, and that is the AC to AC, which is called a cyclotransform or something close to that. Don't remember the exact name, but yeah. Here we have a simple buck converter, or this is a buck converter, just to explain how the schematic or the circuit diagram. So here we have a switch, and then a controller which controls the switch. What does it do? I'll explain. And then we have a diode, we have an inductor, we have a capacitor, which is the LC combined together acts as a filter to produce a DC supply. So here we have the input voltage, which is a DC. So what exactly is happening in a power converter is waveform shaping. We are trying to change the DC waveform into another DC waveform. For example, here we have, let's say 10 volts, and then we want to have 5-volt output. How do we do that? So that is what we are going to do using power converters and without having any losses. There is an easy way to do it. You can just have a power supply. We can have a power supply and then use a voltage divider. You can use 2 resistors, and then even the output power will be, and if the resistor values are same, you can get 5-volt over here. And then if you have a 10-volt supply, why don't we use that? That is what we initially did. But then when we use a voltage divider, energy is being lost through the resistors. So heat energy, in the form of heat energy, the loss is around 50%, which drops the efficiency of conversion. So you're wasting energy. You're wasting energy as a form of heat, and it's just it is just being emitted into the environment, and it's just a loss. So we don't want the loss to happen. We want an efficient way to transform the DC waveform into another DC supply. So here, what exactly happens? So when the DC source is going in, we are using a switch to control when the supply should go and when it shouldn't. So as you can see from here, it goes to a continuous supply, and then it changes into a step like input. That is, you can see over here. This is in this diagram, as you can see, I'm marking it. So this is the graph where you can see that step input is being given, or it's a pulse input. So when it's on, the switch actually allows the current to pass through. That is, the voltage is supplied, and then when there is off, this is the off period. So on and off. So how long do we keep it on and how long do we keep it off? And that is being determined by the controller. So that is the function of the controller to determine the time for the on period and the off period, which is called as the duty cycle. These are important terminologies which maybe you may be familiar with it, but you can definitely look it up. So here we have the duty cycle. That is the ratio between the on and off, or we can consider it as, in this case, it is the V out by V in ratio, or it is the T on by T off. It's the same thing, how long you keep it on. So in this case, let's say it's just 50%. So that means it is on for half the time and then off for the rest of the time. So that is how we have fixed. This is a fixed duty cycle. We don't have anything to control. We'll talk about control later. Then what happens after you pass this through this side of after the switch? What happens? So we have a diode which has a negative direction over here. The negative, and then the positive is here. That is the anode and cathode. So that means the flow doesn't happen over here when it's on. When it's on, it goes through this side where we have the inductor, and then here is an example of what happens in the inductor, that is in this graph over here. So the inductor, when you pass a pulsing input, it charges. The inductor gets charged. So this is the charge cycle. As you can see, when the supply is on, slowly the inductor gets on and it gets charged to and reaches the maximum value. As you can see, the sawtooth kind of waveform, it slowly charges it and then reaches the maximum point. And then we turn it off. That is, the switch is off. And when the switch is off, you can see the on state. This is the on state. Here it is. This is the on state. We are talking about the on state. And that time you can see the red mark of how the flow is happening, how the flow of the current is happening. And then when the switch is off, that is here. Can you see the switch is being off? That is when this period, the duty cycle is off at this time. That is a 50% on, 50% off. And during that time, so the flow happens in this cycle here, then it passes through the diode, it circulates inside the second half of the model over here, in the second half of the circuit. So then the discharge cycle happens. So here you can see the discharge happening when the switch is in off state, and then the same thing repeats and it keeps happening. So that is why we have a sawtooth kind of waveform after the inductor. This is what you get if you try to analyze the circuit, and if you try to find what exactly is the output at this point, we would get a sawtooth waveform. And then we have the capacitor, which, what does it do? What does the capacitor do? It acts as a filter over here, which is the filter is, we don't want an AC value. This here, can you see we have a frequency that is, it keeps repeating and it doesn't have a constant steady value. We want a constant steady value, that is a DC value of 5 volts. But here it's not 5 volt, it's probably 0 to 8 volt, and then it comes back again, it goes or maybe 2 volt to 8 volt, and then it doesn't reach 0, and but it keeps going. It can reach 0 too, but for the example part of it, I'm just saying it goes from 2 volts to 8 volt and then again comes back. So we are not deciding that. We want a constant 5 volt output. So what do we do? So we have the capacitor actually takes in the AC component. So this component, that is the sawtooth waveform, has two things in it. It has the DC and the AC part. And the AC part is being filtered by the capacitor. So the capacitor pulls down the AC component and it filters it away. And then we have the DC part, that is the average value. That is the average value of the sawtooth waveform that you can see here. I'm sorry, I just messed up the whole slide. So here we have the constant. We have another. I'm trying to get another color, but yeah. So you can see that you have the violet line, which is actually the average value, which is what we desire. And it doesn't just immediately go there. It takes some time, and then it reaches the steady state value. That is what we're going to talk about next. So then we have the load resistor. That is the load resistor will have the average value through it. The average value will pass through it because, and then when we try to take one sec. Yeah, when we try to find the V naught, that is like through an oscilloscope, we find that we have 5 volt steady DC. So that is what we desire. So we are able to convert from 10 volts to 5 volt. This is just an example of how power converters work. Why do we care about power converters when we are just talking about solar panels? That should be what you're thinking, or maybe you actually somehow intuitionally got the understanding of why you need it. So let's talk about that next. Here we have the complete converter. Here I have a full setup. Yeah, I could have done the explanation over here. So, but here we have some more terms. So here to explain, this is an exact system where we have, this part comprises the controller. This is the controller, and then this part of it is called the power stage. This is the power stage, and then we have this is the controller, and then this is the filter. You have the filter stage, and then this is how the whole converter is done. Described. And imagine we don't just have a converter like that. So first we have to design it, and I'll talk about why we need a converter for the solar system. So the power stage need to be designed for the requirement of how we want the output to be. We want, when we have a 10 volt input, we want the 5 volt output, not like another 8 volt or maybe 2 volt. We can't compromise on output. We need what we require. So how do we design for that? So there are certain formulas to design it. So I'm not going to teach everything. You can definitely look into it on how to design a power converter. Like for example, a buck converter, you can just go Google it, and they definitely have the details. And it is definitely a difficult concept to understand how exactly it works. I try to explain the basics, but you can look into it and see what all the important things you need to learn from and maybe design and try to simulate it through a simulation software like PSpice or MATLAB or anything simple and fundamental. Here we have the waveform that is expected in the output. See, even though I told you the output is going to be a constant DC, that is the ideal situation. Ideally, we want it to be like that, but doesn't mean that it's going to happen that way. See how the waveform actually drops down and comes up. That's because the load is changing. In the previous situation, we have a fixed load condition, and now we are going to transition to understanding why we need the power converter in this solar system. So in the previous example, that is here we have the solar load, which is just a single load, and we're not changing the load at all. But it doesn't happen all the time like that. We have to have we might connect it to a different source. We can have a battery connected to it. We have different appliances. We have different requirement. We have different power requirement for different devices. So how do we compromise for that, and how do we design for that? So the power converters are the one that is the interface between the supply, that is the source, which is the solar panels, and then to the end result, that is where we are trying to produce the power to, where we are trying to convert the power to. So here we have so when the load is changing, for example, we had a bulb and then we changed the load to another system. For example, we changed it to a fan or another charging device. How can we how does it affect it? So we are going to affect it. We are going to affect the whole system, and then we don't want that to keep happening. We don't want to keep designing the whole system again and again. Once we keep it in place, we want to have it fixed. We don't want to keep changing it. So that's where the controller is used. We have an algorithm, or we have a controller which gets the feedback from the previous instance. So it measures the previous. You can see this part where it takes the feedback from, that is the output from the output is actually given as an input to the controller, and then it actually changes the output again. For example, this is a fun way to understand how a controller works. Let's take, I have a pen over here. I think you can see it. I'm trying to balance it on my finger. Here, I'm going to be the controller. I'm going to control by balancing it. How much can I balance it? Okay, I'm doing a bad job. I can't balance it. So I'm trying to balance it. So I'm going to hold it. I'm not going to balance it. I'm going to drop it. So once it starts to fall towards the left or towards the right for you guys, when you see it, I'm going to try to move my finger over here. Why? Because I'm trying to control it and trying to balance it. So what is the feedback over here is I'm seeing it fall towards this side. So the brain is getting a feedback that is falling towards this side. So I have to move my hand towards this side to balance it. Can you see it? Yeah. Here. If you try to balance it, if it's falling towards this side, you want to balance it. So you move it here. And if it's trying to go towards this side, you want to balance it and make it come here. So same way, the feedback is, suppose you want to get 5 volt, and then the output voltage is increasing to a 6 volt, and then we want to drop it down. So how do we drop it? So that is where the controller controls the duty cycle and change the duty cycle by varying it and produce the output again. So here you can see how the change happens. Here the load is changing, and then again it's coming to a steady state. So when it's constant output, when it's a constant, that is called as steady state. That means it is being fixed. It doesn't have any change in it. So it is staying the same. The controller is having the same response again and again. So it's not changing anything. But here, when we have feedback for this part, so the controller is working. It's working its way to come up. Can you see that? It's trying to come to the steady state. So this part where the controller tries to come to the steady state is called the transient response or dynamic response. It's the dynamic part. Dynamic response, because there is something changing. It's not steady. It's changing because the load is changing or some conditions are changing. In this case, we are just talking about the power converter. When we come into the solar panel, then you will understand why the dynamic response plays a crucial role. And here we have the load current as well, describing how you can see the sawtooth kind of waveform, the triangle kind of waveform, that is the load. That is the inductor current. We talked about how this is what the inductor is giving out. because of charging and discharging. And then the average value, that is the load value. You can see how it's being passed through the load. This is just a explanation of the whole converter system, which is the main crucial part. For me, the most challenging part is the controller design, because you want to control in such a way that you want to have the steady state in a certain amount of time. You don't want to wait for the converter to, for example, if it takes 1 hour to come to this part, what is the use? I mean, we want it to happen instantaneously. So usually it is in like 250 microseconds. Actually, yeah, in microseconds. You want to, and then you don't want to have these noises. Here you have some noise. You don't want the noise to be too much. You don't want the noise to exceed a certain limit. So there are different constraints when you design it. You will see it when you try to learn more about it. And yeah, that's the brief about the power converters. And the controller is a major part. For this to understand how the controller works, there is a course called control system, which you need to understand and study different concepts. You'll understand about stability, you'll understand about the maths behind how this is working and how you convert it and how you design this part of the system. And then for the power stage, you have to learn about the power electronics, power converters, how to design it and how it works, and how placing these in certain ways can affect the waveform, that is shaping the waveform as you need. So yeah, moving forward, here is an example model of how the power converter is used in the PV module, that is the photovoltaic cell, the solar panel. So we have the sun, which is fully or which is fully radiating the heat. That is, it doesn't have any shade. It's open. It's a sunny day, completely sunny. That is this part. And then we have the partly cloudy, and then we have the completely cloudy. So what is being changed is called the insolation. Insolation is the amount of it's a term called insolation. Insolation or irradiance is the amount of light or a light being light touching the Earth's surface. So as the clouds are affecting it, the amount of sunlight or the intensity or the brightness level is dropping, which can affect how the energy is being generated, or how it is being extracted from the solar panel. Here we have the DC to DC converter, which we were talking about. Here we also have the load as an electrical vehicle, and also we are charging a battery along with the electrical vehicle. Maybe it can be used for the electrical vehicle and also charging the electrical vehicle at the same time. And then we have the MPPT controller, which is to use specifically for solar system. So what exactly is MPPT, and why are we trying to get that? As you can see, we have different conditions which affect the solar energy. It is not a linear energy resource. It is a non-linear system, because we have certain parameters like insolation, because the sun is the main parameter, and then we have the clouds which play a crucial role and come and affect them. And how it affects the efficiency is you can see the curve over here, which is the PV curve of a general solar panel. Here we have different the first one, the top one, is where you have the maximum sun, that is the fully sunny region. At that time you can see the voltage, the maximum voltage that can be used to extract the maximum power is at this point. So how do we know that? How do we know this is the maximum Vmax? How do we know what is the Vmax value? And how do we know that accounts for the maximum power max? So this is what is we're going to try to find the maximum power point tracking. That is MPPT. We are going to track this point, and if the sun is changing into this position, we're going to track this point. Or if the sun is being coming to a more cloudy position, from partly cloudy to more cloudy, then we're going to track this point. So the tracking is what we are trying to do, and that is why it's called the maximum power point tracking. In each case, you can see the wave. You can see the graph to explain how. Suppose you choose this Vmax for getting the power for getting the power extraction from the solar panel, and you have only this much power, and instead you can actually get this much power, what would you choose? You want to get the maximum power out of it, right? So uh, that's why we would try to get the maximum power. I see a raised hand. uh, if wait a second. If you have a question, can you please write it down so that you can ask at the end? I'll appreciate that. Yeah, don't forget to ask questions for sure. I want to answer all your questions, and I just want to make sure we have everything in time. How are we doing with the time right now? Oh, okay. We have taken a lot of time in this. Okay, let's move on to the MPPT algorithm. Here we have what exactly is the maximum power point tracking. So to extract the maximum power, like I said before, in any given condition. So the different conditions are when the irradiance, that is the sunlight, varies, and then we have different load characteristics. Suppose for the example model I gave a battery load. Suppose we have a different load. How does it bother? How much do we need? Based on the load requirement, we need to change so that the maximum power is extracted, right? So that's why we have the power converters to control the power converter by changing the duty cycle ratio. So keeping the switch is what we control, and to control that switch, it is such a complex mechanism. It's a complex relationship of how everything works together, and then we are trying to get the maximum power out of it. So here we have I'm trying to move forward with this because I already tried to explain this part. We'll talk about some basic characteristics of a solar panel. Here we have the current and the voltage, and see how different insolation levels, so that is different sunlights, affect the waveform. So here we have the maximum point, here we have the maximum point at each different condition. So this is what I was talking about. Suppose suddenly the day is sunny and then the clouds come and interfere with the sun, and then we can't expect to have the same maximum power point. We have a different power now. So what do? We have to move the requirement. We need to get the maximum power from it. So the controller will work in such a way that we can extract the maximum power from it. Then we have another curve that is based on temperature dependence, and how temperature affects the conversion factor, and then how temperature affects the IV curve. Next, I see another hand raised. Please just note down the questions to ask at the end. I'll be definitely there to answer your questions. So don't worry about that. I want to keep moving forward. Uh, so here the effect of maximum power point, how it is being changed. For example, if the sunlight is changing, so you can see that if the sunlight is dropping, again we're talking just like the previous part, we are seeing how the temperature and sunlight is being affecting the maximum power point, and how do we track it, and what is the algorithm used. So I'm going to talk about three basic algorithms, which is quite famous. So we have the hill climb, or the perturb, and observe. What is the meaning of perturb? Perturb means, like, suppose I'm trying to balance the pen. Again, let's go for the balancing pen problem. So if I'm trying to push it a little bit this side, so that is, I'm trying to see if it's still balanced. So when I give it the push, the small push is called the perturb. So you're trying to, like, see if it says any kind of response. If I try to push too much and if it's going to fall, then I need to know that I should stop pushing and I should control it. So the same way perturb and observe works. It is going to increase the duty cycle a little bit and then see if the maximum power is reached. So we are actually trying to reach the maximum power point by adding the duty cycle to the controller. Like, each time we want to see how the algorithm works. So I'm going to skip the wordings. I'm going to explain it to you guys. So here we have the algorithm. There is the flow chart. We detect the output voltage and current, and then calculate the power by just having a multiplier, and then see what happens to the current power and compare it to the previous power. If it is more, for example, the previous power is more than the current power, the current power is more than the previous power, then you want to increase the duty cycle and see how the next reaction is. So we have the perturbation that is positive, and then the change in power is positive. That means the next perturbation should be positive. So that means you can see in this graph over here, let's say that A is the maximum power point. So, and we start off with this point. and then we keep moving here. We add because the power keeps increasing, and then we keep adding and we keep adding, and somehow we reach to the A point. And once we reach A, and then it's going to see that the next point, when you go further, it's going to be higher than A, but it's going to be lower than A. Sorry, it's dropping. The maximum power point is A. Let's consider the maximum power point as these for the time being. And then afterwards, you can see that from A, it drops down to B. It drops down to B, and then again it jumps to C. So there is a fluctuation because it doesn't actually stop at one point. Once that is the only disadvantage of this algorithm. Once we reach the point, again it checks what is the next power. It jumps to C, it jumps to B. It keeps fluctuating. And imagine if suddenly the sunlight varies, suddenly the sunlight increases, and then you jump to the D. And then once you jump to D, again the same thing happens. It goes to E, it jumps to F, and there's an oscillation. And if there is a rapid change in sunlight, the algorithm is going to get messed up. So that is the main disadvantage. So the disadvantage of using this is when rapid sunlight variation. If there is a rapid sunlight variation, then definitely this algorithm will collapse. You can see more details. You can read papers about it to understand exactly more in detail, because I want to cover the rest of the algorithms as well. Next, we are talking about the incremental conductance. Here we have that is the PV curve. We talked about the PV curve, right? So that is how the curve is. So when you actually find the dP by dV, so we are using differentiation. So what exactly is differentiation? I was going to ask you guys some questions, but I think I'll just answer it. So when you find the differentiation, you're going to find the slope at a particular point. So you're going to find the slope at each point and see if the slope is increasing. If the slope is increasing, that is, once we keep going forward, that means the slope is increasing until we reach a point where the slope becomes zero. That is the maximum point. So that is what we mean by dP by dV equal to zero. So that means the maximum point is reached, and that is where we want to keep the voltage at. We want to keep the voltage there. So we have a sensor. Obviously, we have a sensor to detect this. So then we give it to the controller, that is the feedback. And then the feedback will make sure that the duty cycle is changed, and then it goes up and reaches there, and it stays there. And suppose there is a change in load or something changed, and then again, then there will be a change in the power point, and we have to see based on that, if again we have to track it. So this is where you use to track it. If the slope is greater than zero, then that means we are in the left side. We are not at the maximum power point yet. So that means we need to go positive. And again, if we find the slope as negative, that means we are on the right side of the maximum power point. So that means we need to go left. So that means we need to reduce the duty cycle and keep reducing until we reach the maximum power point. So that is how we track it. We are actually going through the curve. See, previously we did the difference between this and hill climb is that we have a reference voltage in this, and then we keep adding it based on we find the differentiation. In the previous thing, we just keep adding, and it takes time to actually reach the point. Here we can have a different step size. There are different factors in it leading to how we can understand this working. Okay, then here's the graph to show you the the conductance. So the conductance is actually the I by V, which is the opposite of resistance. That is I by V ratio gives you the conductance. So that is the incremental conductance method. Next, we'll talk about the dP by dV or dP by dI feedback control, which is very similar to the previous method. So that's why I took it. We have another bunch of methods to do MPPT, but these are some simple techniques and intuitive ones. So I chose them for our understanding. So you can see the algorithm. We sense everywhere. We sense the voltage or current, and then we find the difference in power. We find the difference in voltage. That is, again, we find the slope. And then once the slope is greater than zero, we actually determine a sign for it. Instead of moving forward or something like that, we have determined a sign. That means 1 is considered as positive. So we are adding the duty cycle. And then if we are at the power point, that means we don't need to add anything. So we can just remain at that point. So the sign becomes 0. And then the sign is negative when the duty cycle needs to be reduced, when we need to come down in the maximum power point tracking. So that means the dP by dV should always be equal to 0. So that is when you reach the maximum power point. So when you reach at that state, you want to stay the same. And here you can see how the different factors affect it. Like the irradiance and temperature. Once it increases, so you reach the point, and then again you move forward, you go up, because it's changing. Maybe you come down, you don't know. Based on what the correct condition is, the controller will automatically adjust, because the algorithm is defined in such a way that we always find the MPPT and the efficiency is maintained. Even though we have the MPPT, there's like not 100% efficiency. We can't find 100% efficiency in any kind of system. There are some losses, like switch losses. There are losses in power converters. There is loss in solar panel extraction. But at that instant, we can get the maximum power out of it. So that is why we are specific about the maximum power point tracking. So yeah, that's about the basics of the algorithm that I wanted to discuss today. And I want to show you quickly, and then we have the different comparisons of which technique to use. And as a designer, if you want to design a power converter, and if you want to design the whole system, you need to know what is important for you, what parameter is important, and what do you have, and how much cost. So this is just to show that which kind of method you want to approach, and what is easy, and what is time consuming, and which one is efficient, and which one works in the way according to your needs. So the comparison is being made over here. I don't want to go in detail about this. You can definitely look into it. Just wanted to share something about it, because if you want to design something. Okay, then we have the question answer. So I see a lot of people raising their hands. Before that, I have one more thing to share for you guys. Let me show you the solar. Can you guys see this right now? I'm actually sharing my MATLAB Simulink model of a simulation of how the PV system works. Here you have the here we have the PV panel, and then we have the simulation of how or just a model of how the PV works. I'll show it to you guys. See, we have a PV simulation of how the photons affect. So this is just a system to design this is to simulate the behavior of a solar panel. You can actually do that in Simulink in MATLAB, and we have a code for it. And it is a predefined code. I didn't write the program for this. You can find the model, which is designed by MATLAB programmers who are working in the company. So we have how the solar energy is being produced. The solar the output from a solar panel. You can see it. I'm trying to run it. Yeah. So this is the voltage and the current waveform being generated. So that is what I wanted to show you guys. That is the solar panel part. Then we have the MPPT controller here, which is what we were talking about. Here we have the P&O algorithm, which is a MATLAB code. You can see that being defined over here, how the MATLAB code is written, just like the algorithm, where you see that we add the duty cycle, then based on the condition, if else, and we find the differentiation of the power, and everything is similar. We have to write the program for it. And then here we have the scope output for it. So this is going to work according to what we need, like control. This is going to keep changing. We need to run the whole system. We cannot run just the MPPT controller, which is actually controlling the buck boost model here. This is the buck converter model we were talking about, but this is a combination. This is a different setup. We talked about the buck converter, but this is a buck boost converter, where you can do both operations simultaneously just by changing the input and output. So here we have the control signal, which is how the duty cycle is being controlled. And then we have the buck converter output, which I want to show you last few minutes, guys. Can you see how we have the buck output to a certain voltage level we want to reach at this point? I think this is probably boost. It's giving a boost output, and then I want to show you the final model of, we have a resistive load over here, and then we have the final working model of the MPPT controller. Here it is. So we want to have a steady 300 watt. This is a power calculated. So we have a steady 300 power achieved over here, and the above is just the power generated from the controller, and we want to make sure that it reaches, using the MPPT we have a steady value of 300, and it doesn't keep shifting and doesn't change. We control it according to the MPPT algorithm, and then we simulate the behavior of a solar panel. So that's about it, guys, that I wanted to show you guys. Then going back to the presentation. Okay, let's go to the question and answer. Thank you for your time. I appreciate it, and hope you learned something new, something interesting. Ma'am,
Yes,
are you
yes,
still there?
yes, we're there. Thank you very much, Mr. Varun. That was a really wonderful session, and we convey our heartfelt thanks to you for sharing your valuable knowledge with us. So we'll take up few questions from the participants.
Okay.
Yeah, the first one is the replacement of counter electrode in DSSC is very essential now. What's your idea on it?
Could you please repeat that? What is that?
The replacement of counter electrode in DSSC is very essential now. What's your idea on it?
I'm not very familiar with that. Is it related to power electronics side?
Okay, that's fine. So let's move on to the next question. Can you
Yeah.
please explain the effect of temperature variation on PV system output?
Yeah, that's what we were talking about in the graph. I have it in the, here we have the varying temperature effect. This graph.
Actually, excuse me, Mr. Varun, your PowerPoint is not visible to us. Still, the MATLAB screen is there.
Oh, okay. Let me change it.
Yeah.
Can you see it now?
Yeah, that's fine.
So here we have the effect of the temperature. See how the varying the temperature affects over here. The power point, as you decrease the temperature, the maximum power point actually moves to a higher value, and then we track it using the same algorithm, and then once the algorithm is in place, the tracking happens no matter what the condition is. That is why we are using the MPPT. So whatever the condition at any given point, at any given situation, you can have so many clouds, you can have rain, you can have whatever, the maximum amount will be obtained at any given time. That's why we do the MPPT. I hope that answered your question.
Yeah, definitely. Thank you very much. The next question, will the efficiency remain the same if the output load is changed?
Yeah, it will remain the same. It'll remain the same, provided your algorithm works that way. You have to make sure that you have to design the power converter based on the factors, like the controller should have less transient response. Like suppose I want to create a, let me take this to a blank slide. Why does this work? Okay, so suppose you have to design the power converter in such a way that you saw the response. Hello, can you hear me?
Yeah, we are audible, Varun.
Yeah, I feel like this is stuck. Wait. Yeah, my PowerPoint is stuck, so I don't know what's happening. Let me share again. Okay. Oh, I don't know why I'm not able to access my own PowerPoint. Okay, so yeah, the efficiency can be kept in place by maintaining your the control algorithm. Once the load is changed, so the tracking happens again. So the tracking happens, and then you find the maximum power point. So obviously there's going to be a time delay, and it depends on what kind of algorithm you use, because there is different methods, different approach, and whatever approach you use, you're going to have the certain amount of efficiency for that. So definitely you'll get the maximum efficiency no matter what if you're using MPPT. That's the thing. At any given situation, we get the maximum power point, but provided you have to sacrifice if you're using PNO, that is the perturb and observe, which is most commonly used, I think you would get about 96% of the efficiency. That is the maximum you can get, provided that is also cheap to establish and simple. But if you want to go for fuzzy logic controller that uses some neural networks and understanding of a different data science background to it, then definitely that's going to cost more. You're going to have a fuzzy logic controller, which is expensive, and then you have to have certain parameters for that. Maybe it can become more faster to reach the maximum power point, but the efficiency might be still lower and cost might be higher. So these are the factors that will affect it.
Okay,
I
fine.
hope, yeah, that answered your question.
Yeah, definitely. The next question, can MPPT techniques be applicable for all ranges, maybe for voltage, I think they're asking.
Oh yeah, for any voltage you can use it for any kind of voltage.
Okay. The next
Yeah,
question, what?
but for that it will be dependent on the power converter, design of power converter. You need to know what is the input, you need to know what is the output, and that's where the design of power converter, the power stage, the control stage, the filter, it all happens. So everything should work in a complete setup based on what are the requirements. You need to know the constraints, the parameters regarding that before you design it.
Yes, Varun, thank you very much. And one last
Yes, ma'am.
question. What is
Okay.
the main purpose of DC to DC converter?
The main purpose is the requirement that we need to convert for different applications. Suppose in your computer, your battery produces certain amount of voltage, but does that require you to run the USB port? How much energy do you need? The power supply is giving you 220 volt. Are you using directly 220 volt to your charger? No, you're actually rectifying it. You're using a DC source. So there you have an inverter. But for the DC conversion, it's happening in the computer itself. There we have a bus, the power bus, and then we convert it based on requiring, for example, the audio system can use just 3 volt, or maybe the CPU processor uses 5 volt. So then we need a buck converter inside to convert it, and we convert it, design it accordingly. And then there is like certain factors like timing, and when it comes to computer, that's another complete different ball game.
Yes, Mr. Varun, thank you very much for that. That was a great session indeed. And we have got an excellent feedback from participants. Like they have said, it is a great session, and many have said that it's excellent. Our YouTube viewers have given excellent feedback on your session. Thank you very much for that.
Yes, ma'am. I appreciate it. Thank you so much for your time. I hope you have a great day and
Yeah.
keep learning. That's it for today.
Yeah.
Thank you,
Thank you
guys.
very much. Thank you for
Bye.
joining with us, Varun. Thank you.
Bye bye.
We thank all the participants for joining with us today. Hope you'd have enjoyed the session and all our questions have been answered by our speaker. I would like to announce about our upcoming webinar. Our upcoming webinar is on Machine Learning Using Python by Dr. Doreen Robin, Founder and Director, Computational Intelligence Research Foundation, Chennai, scheduled on July 2nd between 4 p.m. and 5 p.m. I request all the faculties and students to attend the webinars and get benefited. Meet you all in the next session of our webinar series. I once again thank all the participants as well as the speaker of the day for taking their valuable time with us for the webinar session today. Thank you very much. The feedback link will be posted in the chat box. Yes, it has been posted. We request the participants to fill up the feedback form within 10 minutes after the session gets over. The feedback link is posted in the chat box in Zoom as well as the YouTube live streaming page. This will not be shared through WhatsApp or through email. And the participants are requested to complete filling up the feedback form 10 minutes after the session gets over. The feedback link will be closed exactly after 10 minutes.